Permutation. When we study combinatorics, n factorial is very important. And we learned this before. So n factorial is a product of natural numbers 1 times 2 times 3 times 4 until n. Sometimes people write it in a descending way, so n times n minus 1 times n minus 2, so you go down 1 after 1 until you get 3, 2, 1. Either way is fine, and we often use ascending way to write n factorial. So for example, like 5 factorial, it can be written as 1 times 2 times 3 times 4 times 5. So, and then 2 times 3 is 6. 4 times 5 is 20, so this gives you 120. And another thing you can see there is, now 4 factorial is 1 times 2 times 3 times 4. So of course you can easily calculate the number, the product of 4 factorial. What I'm trying to say is, now if you look at 5 factorial is 1, 2, 3, 4, and then you also have this one. So therefore 5 factorial can be written as 5 times 4 factorial. And this is generally very true for any n. So if you have n factorial, it will be n times n minus 1 factorial. Make sense? Okay, and this is a very important, useful fact about n factorial. Another one about n factorial people need to realize is 0 factorial. Okay, 0 factorial, because there's no natural number here, so we define 0 factorial is 1. Okay, this is, we define it, so it's a definition. Now let's look at an example. A horse race has 5 entries. In how many different orders can these horses finish? Assume no ties. So because you have 5 horses, and then so you could have 5 different orders. So this first place, second place, third place, fourth, and fifth, the last one. So for the first place, you have 5 horses, so you have 5 possibilities, 5 ways to do the first place. And then after one horse take the first place, then for the second place, you only have 4 possibilities, 4 ways to do it. And then for the third place, you have 3 horses, then 2, then 1. Okay, so this is by the fundamental principle of counting, and we have this calculation now. So you multiply, and this is 5 factorial, which is 120. And this is an example how we use n factorial. But this example also shows us how to consider a question like this. Let's consider a further question similar to this, but it's a little different. Example 2. 8 horses are running in a race. In how many different ways can these horses come in first, second, and third? Assume no ties. So to consider this one, and we will do the same similar discussion like example 1. Now here we have 3 spots: first place, second place, and third place. So for the first place, we know there are 8 horses, so the first place will have 8 possibilities or 8 ways to complete. And then the second one will be 7 horses available for the second place. Then for the third place, there will be 6 horses available. So, and then again, apply the fundamental principle of counting. So this should be 8 times 7 times 6, and that gives you, that's punch calculator here. So 8 times 7 times 6, 336. So there are 336 different ways that 8 horses can finish. Let's look at one more example here. Example 3. Students in a first grade art class receive a flag with 3 horizon stripes. each to be colored a different color. If 24 different colored crayons are available, how many possible ways might a flag be colored? So here we have 3 different stripes. And so say this is first stripe, this is the second one, and this is the third. So now we need to color them with 24 different crayons. Then the first stripe can be colored by 24 different colors. And then because we talk about different, so that means we need to use another color. So there are 23 options now for the second stripe. And then because again, we need to use a different color. So we only have 22 now. By the fundamental principle of counting, in other words, by the multiplication principle, and the total different ways could be colored is 24 times 23 times 22. So we punch calculator to see the answer. So this will be 24 times 23 times 22. So the total is 12,144. 12,144 ways. In our daily life, there are many examples like this to do. And these examples here, there are some common things we can observe. One, we have 8 horses. These are distinct objects. And here we have 24 different colors. So these are distinct objects. And then like this one, we talk about 3 different things to finish. So 3 categories or 3 things to do. And then here the same, we have 3 different stripes to complete, to color. So, and then all these we can abstract to the following definition, which is called permutation. Definition, permutation. Given n distinct objects selecting k a time with constellation of order is called a permutation. The number of permutations of n objects taking k a time is, you can be written this now, n times n minus 1 times n minus 2 times n minus k plus 1. And then the notation is p of nk. This p stands for permutation, and objects taking k a time. And it can also be written as p sub nk. So to see this permutation, and we talk about k a time, so there are k spots to complete. So total, we have k spots here. And then for the first spot, we have n objects to fill. So we have n ways to complete the first spot. But now, and after one object is put down here, then you have n minus objects available for the second spot. So when you finish the second spot, then you have n minus 2 objects for the third spot, and so on. So now, when you have k spots, so this one, by this time, you have n minus k plus 1 objects for the kth spot. Because you can see the first spot is n, the second spot is n minus 1, the third is n minus 2. So then you can see, it's always 1 more than this, right? This is the third. And then it will be, so if you calculate, so there will be n minus k plus 1 for the kth spot. So therefore, and by the principle of counting, fundamental principle of counting, so you multiply these, and that is how many ways we can fill out k spots. So this is called a permutation, and that's the formula to calculate how many permutations we will have. So for permutation, we need to see this carefully. So first, when we talk about permutation, we need to pay attention to the order. Okay, so the order matters. And so for k time, you have k spots, and then you need to see different orders here. And then second, the objects must be distinct. So we have n distinct objects. So when we talk about crayon, and we have 24 different colors, and then for horses, of course, 8 horses are all different. And then the third, no repetition. So once the first spot is filled, then you only have n-1 objects available. So there's no repetition, and you do not have you do not have n again. So similarly, like a crayon. So one color is used, then you cannot use that color again. So no repetition. And then for horses, when one horse take the first place, then you only have 7 horses available. So there's no repetition. And in this case, that is called a permutation. So this is the permutation formula. And let's revisit again. So permutation of n objects taking k time, the notation is also be written this one, p sub n k. And this is notation used by TI calculators like TI 83, 84. And then the calculation will be n times n-1 times n-2 down to n minus k plus 1. So you will have k numbers here, because for k spots, k consecutive numbers, k consecutive integers start from n and then down consecutively for k numbers, and that end with n minus k plus 1. And if you want to use the factorial notation, then you know from the next one will be, and continue here, so it will be down to 3, 2, 1, okay? So before n minus k plus 1, then you will get n minus k. When you keep going down, then it will be n minus k minus 1, and so on, and then down to 3, 2, 1. So if we want to make n factorial, we need to put this to make n factorial. But then we need to divide by the same number, n minus k plus 1, down to 3, 2, 1, right? So this is the one we need to put for the permutation so that we can use n factorial. But we do not have this number, so we need to cancel them, so divide by this. But this started from n minus k down to 3, 2, 1, it is n minus k factorial. So this is also another formula for calculating permutation. And this part is the formula also to calculating permutation. Either one will be fine. So let's look at an example here. Say, find p of tan 3. So this is to find the permutation 10 objects taking 3 a time. So according to the, if you use this way, then you start with 10, then go down by 1 is 9, and go down by 1 is 8. Because you take 3, so you have 3 spots here. So that is sufficient now. And this is pretty easy to calculate. So 10 times 9 times 8 is 72, so you get 720 ways, okay? But you may also use this formula to calculate. Either one is fine, depends on your preference. If you go by this way, then n is 10, so you have 10 factorial. And then denominator will be 10 minus k, so you have 10 minus 3, so you get 7 factorial. And then the calculation actually for hand calculation, you often just want to simplify. Then you talk about 10 factorial is 1 times 2 times 3 times 4 up to like 7, 8, 9, 10. And then denominator 7 factorial is 1 times 2 times 3 up to 7. And then you can cancel 1, 2, 3 up to 7 and 1, 2, 3 up to 7. So you still have 8, 9, 10, and that gives you 720. Okay, so when you write in this way, it looks simpler, but the calculation does not, because you still need to go back like this way. So that's how we calculate a permutation. By the way, make sure you know how to do it. Use a calculator. So like TI-83 or TI-84 and many calculators can have this to calculate. So the calculator, you will go to math, and then you go to probability for TI-83, and then you choose P sub nk. Okay. Let's look at another example. So that in the book 4.2.6, a chess club with 16 members is to choose a president and a vice president. How many potential outcomes are there? Now, since we have 16 different objects, and then also we have pick two objects. So we have 16 taken two at a time, and order matters because president and vice president, you have the order here. So this is a permutation problem. Because we know this is a permutation problem, 16 members taken two at a time. Therefore, this is P16, P of 16, 2. Then according to the permutation, we have 16 times 15 down there. Now you only have 2, so you need two numbers. So 16 times 15, let's look at what is it. 16 times 15. So that's 240. So in this case, there are 240 possible outcomes. For homework, please see assignment 35. Thank you.